Dear students, now I am going to give an important note on partial derivatives using Jacobian. Okay, partial derivatives using Jacobians. Okay, so it is important note using Jacobians. So you have to make use of that partial derivatives using Jacobians. So what is that important note is, suppose if I am having a function f1 of, okay, already we have discussed for a function of two variables u comma v with respect to two variables x y z. Okay, so in the same way if I am having a function f1 of u comma v comma w, three variables u comma v comma w comma with respect to x y z, so x comma y comma z equal to 0. So on the past derivatives you are saying this equal to 0, and suppose if I am having I equal to 1 to 3, I am putting here I am putting here I, so instead of 1 I am putting here I. Okay, if I am putting here I, so what will happen? Ultimately I equal to 1 comma 2 comma 3, I equal to 1 comma 2 comma 3 comma etc., which means f1 of u comma v comma w x y z equal 0, f2 of u comma v comma w x y z equal 0 comma etc. Okay, so are the three so for not etc. for three relations, since we are having three variables, we will get only three functions. So f1 of u comma v comma w x y z equals 0, f2 of u comma v comma w x y z equals 0, f3 of u comma v comma w x y z equals 0. Since we are having three variables, we will have only three functions. So fi means here I takes a value only up to 1, 2 and 3, not more than 3 values that I will take. Okay, so now we can find dou u by dou x and dou x by dou u, and in the same way we can find dou v by dou x, dou x by dou v, then dou w by dou x and dou v by dou w by dou x. Okay, you have to understand dou u by dou x and dou x by dou u, then dou v by dou y and dou y by dou v, and dou z by dou w and dou w by dou z. Okay, and also we can find so many things, because dou y by dou u is also possible, dou u by dou y is also possible, dou z by dou u is possible, dou u by dou z is also possible. So we have already seen in the first case. Okay, now we are discussing about a important note. So for this I am taking first what will be dou u by dou x, so since in the numerator everything is function of u, v, w, and they are functions of f1 comma f2 comma f3, we will get three functions. Okay, f1 comma it is I, f1 comma f2 comma f3, then divided by we are having dou of x comma, since we are differentiating with respect to u, we will have only v comma w in the second and third position. Okay, because first position is meant for u, and there we are having x, divided by here also we are having some here the denominator is common, so we are having dou of f1 comma f2 comma f3, f1 comma f2 comma f3. Here we will have dou of u comma v comma w, u comma v comma w. Okay, so this is our dou u by dou x. Okay, so in the same way we can find dou u by dou y, then dou u by dou z, then dou v by dou x, dou v by dou y, dou v by dou z, and also dou w by dou x, dou w by dou y, dou w by dou z. So you have to keep in mind, if I want to find dou w by, okay, dou w by dou x means, so I am differentiating w with respect to x. So first term will be, first term w means it will be last term, it will be last term. So first term will be x, okay, then second term will be okay, in the place of w we will have in the place of w we will have x. So in the beginning we will have u and v, in the beginning you will have u and v, in the place of w you will have x. If I want to find dou v by dou x, dou v by dou x means, so in the place of v we will have x, and here I will have u, and here I will have w. So here it will be x, here it will be x. Okay, but and in the denominator, okay, and in the denominator of this, okay, for v the denominator will be as I told. For okay, for w the denominator will be different, okay, as I told. So for that you have to first understand what is dou a by dou x, then dou a by dou x, dou u by dou y, and dou v by dou y for the functions f1 and f2 of u comma v with respect to x comma y. That is our original formula. This is important, this is expanded version of that. So if I want to find the dou u by dou x, always we have to keep in mind there should be a minus. So minus of this thing will be here, minus of this thing will be here, you have to keep in mind. Okay, next, if I want to find the reciprocal of this, if I want to find the reciprocal of this, then we can find dou x by dou u also. So dou x divided by dou u is equal to, then also we will have minus of, okay, minus of the numerator, the you will have this whole term will become, okay, this whole term will become our numerator. Okay, I shall write here dou of f1 comma dou of, okay, dou, since u is in numerator you are having u w as common, since if x is in numerator we will have, I shall x y z as common, x f1 comma f2 comma f3, f1 comma f2 comma f3, f1 comma f2 comma f3 divided by f1 comma f2 comma f3 divided by, and here since I am differentiating x with respect to u, so in the place of x I will have u, in the place of x I will have u. So dou of u, and remaining place will be y comma z, y comma z, okay, y comma z divided by, okay, divided by here it is common dou of f1 comma f2 comma f3, f1 comma f2 comma f3, f3, okay, divided by instead of this uw we will have dou of xyz, dou of x y z, x y z, okay, x y z. So this is an important note, okay, under partial derivatives using Jacobian. So now after this we are going to discuss a problem, the problems on partial derivatives, using Jacobian, okay, problems on, okay, I shall type here, problems on partial derivatives using Jacobians. It is problems of finding, okay, instead that we can also write problems on partial derivatives using Jacobians and problems of okay, let it be problems on itself. Okay, now using Jacobians. So now the problem is we want to find dou x by dou r and dou r by dou x and dou theta by dou x. We want to find dou r by dou x and dou theta by dou x. That is, if x equal to r square minus theta square, if x equal to r square minus theta square, comma y equal to 2r theta, then we have to find dou r by dou x, comma dou theta by dou x. So using Jacobians is what this problem actually needs. Okay, now we have to write what is our f1 and f2. So here I am going to take here I have to begin my solution. Okay, solution is, what is our f1? f1 equal to x minus r square minus theta square. Second is f2 equal to y minus 2 or theta. Okay, according to the condition of Jacobian, they have given f1 of u comma v comma x comma y equal to 0, f2 of u comma v comma x comma y equal to 0 is what they have given. So instead of that we are having here r comma theta, that is f1 of x comma y comma r comma theta equals 0 and f2 of x comma y comma r comma theta equals 0. So you can ask, here there is no y and here there is no x, but anyways we have to tell like that. Okay, we have to tell the functions, both f1 and f2 will be the functions of same variables. Okay, functions of same variables. So by that condition since in the definition of Jacobian partial derivatives using Jacobian itself we are having 0, we want to write 0 here, equal to 0. Now we want to write a formula. What is the formula for dou r by dou x? Okay, dou r divided by dou x. Okay, dou r by dou x. The formula is here equal to, we know that using Jacobian means we will have one minus, and after that we will have in the numerator we will have dou of the only two functions f1 f2. Okay, dou of f1 comma f2 with respect to I am doing it with respect to x. I am doing it with respect to x. So I will have, okay, I said here divided by dou of, since I am doing it with respect to x, the first term will become so if I am doing u means the first term will come into the first term, the r will vanish, and I will have x here, and I will have x, comma, and r will get vanished, and I will have theta. Dou f1 comma f2 divided by dou x comma theta divided by denominator is common, dou f1 comma f2 divided by dou r comma theta. Okay, dou f1 comma f2 divided by dou of r comma theta. Okay, dou of r comma theta. Okay, then if I want to find dou theta comma x, means I should copy the same formula and I should replace everything. Okay, control plus C and control plus V. So here in this formula we want to find dou theta by dou x. So dou theta by dou x means the partial derivative of dou theta by dou x with by means of Jacobians means here I am differentiating theta. So r comma theta means theta comes second, so there we have to write x, and the first place is meant for r, so we have to replace that, okay, we have to replace that r comma x, and the rest of the things are common, r comma dou of r comma x. Okay, so with respect to x means first variable will be okay, with respect to x. So if I suppose to do it by means of y means it is okay. Since I am doing it with respect to x, theta with respect to x means okay, theta with respect to x means, yes, am I right? Yes, I am right. It is r comma x. Yes, I am right. Little confusion because it is such a complicated formula and we have to remember that. Okay, so dou of r comma x. Yes, now we are having two formulas and we have to find the values of these things. So the values of these things, so that is equal to, okay, that is equal to, so here we are having a determinant. So what determinant we are having? Here we are having dou f1 by dou x and dou f1 by dou theta and dou f2 by dou x, and here dou f2 by dou theta, okay. Now and here, and we have to write formula for denominator also, divided by, okay, divided by, so there will be a minus, minus of here dou, okay, dou f1 by dou r and dou f1 by dou theta, and here dou f2 by dou r, and here dou f2 by dou theta, okay. So this is the Jacobian, okay, this is the Jacobian we are having for finding above partial derivative. Now I shall copy these things, and I shall paste it in, and I shall paste it very closer to this, and here, so dou f1, okay, and here we will have dou f1 with respect to dou r and dou f1 divided by dou x, and here dou f2 by dou r and dou f2 by dou x, okay, dou f2 by dou x, okay. So we are having dou f2 by dou x divided by so r comma theta. R comma theta means denominator will be same. Now we have to find all the values. So how to find the values? The values will be minus of determinant of. So our f1 value is, our f1 equal to x minus r square minus plus theta square minus 0. What will happen with respect to x means you will have minus r with respect to, okay, and when I am differentiating with respect to x, f with respect to x means both r and theta will become minus r square plus theta square will become 0. So only thing is I will get plus 1. So when I differentiate f1 with respect to theta, it will become 2 theta, okay. When you differentiate f2 with respect to x means since there is no x in f2, it will become 0. Since I am going to differentiate f2 with respect to theta, what is f2? f2 equal to y minus 2r theta. So y will become 0 and 2r is constant, theta will become 1. So it is minus 2r divided by, okay, so dou f1 by dou r. So when I differentiate f1 with respect to r, I will get minus 2r. Both x and theta will get 0. So it will be minus 2r also. So when I differentiate f1 with respect to theta, I will get plus 2 theta. Okay, I will get plus 2 theta. And if I differentiate f2 with respect to r, I will get minus 2 theta. Okay, I will get minus 2 theta minus to theta, and if I differentiate f2 with respect to theta means I will get minus 2r. So in the right hand side also the denominator will be same, but the numerator will vary. So I shall copy the entire thing and I shall change the numerator alone. Okay. So here we are having f1 with respect to, so here also we have to so here we are having f1 with respect to r. So f1 with respect to r means what is our f1? Okay, f1 with respect to r. So we will have x will become 0, theta square will become 0, it will become minus 2r. It will become minus 2r. Okay, it will be minus 2r. Okay, we have to delete entire numerator. So we shall remove everything in the numerator. And we will have dou f1 by dou r. What is mean dou f1 by dou r? So dou f1 by dou r means differentiating f1 with respect to r, we will get minus 2r. Okay, minus 2r and differentiating f1 with respect to theta means we will get 2 theta. Okay, differentiating with respect f1 with respect to theta, differentiating what is our f1? Our f1 is x minus r square dou theta by dou x. Dou we are having dou theta by dou x. So we have written dou f1 by dou r, and dou f1 by dou x means dou f1 by dou x. Our f1 is x minus r square plus theta square, so with respect to x means we will get only 1, and if I write dou f2 by dou r means it is minus 2 theta. And if I want to write dou f2 with respect to dou theta means dou f2 with respect to x. Dou f2 with respect to x means, so since there is no x in f2, it will be 0. Okay, it will be 0. Now we are having determinants, that is now we are having Jacobians. Okay, so by using these Jacobians, we want to find the partial derivatives, that is equal to minus 2r minus 0 divided by it is 4 r square plus 4 theta square plus 4 theta square. Therefore we will have dou r by dou x equal to, okay, dou r by dou x, a partial derivative dou r by dou x equal to, we can take 2 commonly outside, we can take 4 commonly outside, and it will become plus 2. So we are having r divided by 2 into r square plus theta square. R square plus theta square. R square plus theta square. And here, and for this we are having, minus 2 and 0 is 0, then minus of minus it will become plus 2 theta, means it is minus of minus 2 theta minus of minus 2 theta, that is it is plus 2 theta. Okay, 0 minus of minus, it is plus 2 theta. So 0 plus minus, it is plus 0 minus 2 theta, means it is plus 2 theta. Already we are having one minus outside, so that minus is here, divided by, it is 4 r square, denominator is common, so it is 4 r square plus 4 theta square. 4 theta square. So that is equal to this equal to minus of, we can take common outside 2, so minus theta divided by 2 into r square plus theta square. Okay, so this is our dou theta by dou x. This is our dou theta divided by dou x. Dou theta divided by dou x. Okay, so these two are our results. So I hope you all understood the problem. The problem is simple, but only thing is the formulas are little complicated than the previous formulas, but when you understand the concept, it might become easy. Only when you have after your understanding of concept and formulas only, you may feel that it is easy. Okay, so tomorrow we shall discuss on the problems under the topic Taylor series. So on the Taylor series, we are going to find the Taylor series for the function of two variables. Okay, so thank you all for watching this video. I hope you all enjoyed this video. Thank you all once again.